The James Webb Space Telescope has dramatically reshaped our understanding of the universe, revealing unprecedented details and capturing awe-inspiring images of the cosmos. Yet, some of its recent findings have raised serious concerns. Notably, renowned physicist Brian Cox has confirmed that the telescope recently observed a staggering 250% increase in Betelgeuse's brightness. This sudden change begs the question: is Betelgeuse on the brink of a supernova, and how might that impact Earth? To answer these questions, let's first dive into the background of this star. For centuries, the night sky has served as more than just a backdrop of twinkling lights. It has guided travelers, inspired romance, and provided a window into the vast history of the universe. Among the countless stars that have captivated humanity, Betelgeuse holds a unique place. Situated within the iconic constellation of Orion, this red supergiant commands attention with its striking glow, outshining its stellar neighbors. Located approximately 650 light-years from Earth, a distance so immense that it defies imagination, Betelgeuse looms large, measuring around 6 quadrillion, 150 trillion, and 650 billion kilometers away. Why does this distant star captivate us so? Betelgeuse is more than just a star. It is a cosmic giant, a red supergiant of colossal proportions. If Betelgeuse were placed at the center of our solar system, its outer edges would extend beyond the orbit of Jupiter. This star dwarfs our Sun in both size and significance. Yet, it's not only Betelgeuse's size that makes it remarkable, it's also its unpredictable nature. Unlike our Sun, which maintains a relatively stable brightness, Betelgeuse exhibits dramatic fluctuations in luminosity, which has long fascinated astronomers. The true wonder of Betelgeuse is that observing it is like peering into the past. The light we currently see from Betelgeuse began its journey over 600 years ago, around the time the Renaissance was dawning in Europe. The finite speed of light means that every flicker we witness today comes from a time long gone, offering a glimpse into an era when humanity's understanding of the cosmos was still in its infancy. Each observation we make connects us directly to that distant past. But recent observations have sent shock waves through the scientific community. The James Webb Space Telescope has detected a dramatic surge in Betelgeuse's brightness. This brightening started in early 2023 when the star began shining more intensely than it has in recent history. This surge in luminosity is particularly striking because just a few years earlier, Betelgeuse had experienced a major dimming event between late 2019 and early 2020, an occurrence that baffled astronomers worldwide. Known as the Great Dimming, this unusual decrease in brightness raised questions about the star's internal processes, leading to speculation that Betelgeuse could be nearing the end of its life and might soon go supernova. Betelgeuse's current brightening marks a sharp contrast to its recent dimming. During the Great Dimming, the star's brightness plummeted to its lowest recorded level, stirring alarm and curiosity among astronomers and skywatchers alike. The dimming, noticeable even to the naked eye, was unprecedented and prompted many to question whether the star was undergoing a significant transformation. Theories surrounding the Great Dimming range from a massive outflow of gas and dust from Betelgeuse's surface to the possibility of a cool spot, a region of lower temperature on the star's surface. These theories painted a picture of a star in turmoil, shedding its outer layers or experiencing internal shifts. Researchers like Kenichi Nemoto from the Kavli Institute and Hideyuki Seo from Tohoku University offered various insights, including the discovery of a regular pulsation cycle in Betelgeuse's behavior occurring every 420 days. This cyclic expansion and contraction could explain some of the variability in brightness, but the exact cause of the Great Dimming remained elusive. As Betelgeuse's brightness returned to normal levels, many questions lingered, including the mysterious drop in temperature during the dimming event. Astronomers speculated that star spots, similar to sunspots on our Sun, could have played a role in this temperature shift, potentially influencing the star's radiative output. The implications of Betelgeuse's behavior extend beyond mere curiosity. Understanding the life cycles of massive stars like Betelgeuse is critical to understanding the synthesis of heavier elements in the universe. These stars produce elements heavier than helium, which are essential to the formation of planets and life itself. Betelgeuse's dimming and brightening episodes provide valuable insights into the processes governing massive stars and their eventual supernova explosions. As we consider the possibility of Betelgeuse going supernova, it's important to note that while such an event would be spectacular, it poses no immediate threat to Earth due to the star's distance. However, a supernova would have a profound impact on our understanding of stellar evolution and the mechanics of star death. The recent surge in brightness detected by the James Webb Space Telescope raises fresh questions about the star's future. Is Betelgeuse on the cusp of a supernova, or are these fluctuations part of a longer, more complex stellar cycle? Scientists continue to monitor the star closely, as its ultimate fate remains one of the most anticipated events in astronomy. The James Webb Space Telescope, with its advanced infrared capabilities, has proven instrumental in observing these changes. Its ability to peer through cosmic dust and capture high-resolution data on celestial objects like Betelgeuse gives us an unprecedented view of the star's internal dynamics, shedding light on processes that were previously hidden from view. In conclusion, while Betelgeuse's recent brightening may not signal an imminent supernova, it does provide a unique opportunity to study the late stages of stellar evolution. Whether Betelgeuse is preparing for its final act or simply exhibiting its natural variability, the insights gained from this cosmic drama will deepen our understanding of the universe and the life cycles of stars. The red supergiant phase represents a critical and volatile period in the life cycle of massive stars, occurring after they have exhausted their hydrogen reserves and begun burning heavier elements. During this phase, stars like Betelgeuse experience significant changes in brightness due to convection currents, thermal pulsations, and mass loss through powerful stellar winds. This natural variability raises compelling questions about the potential for predicting supernova events. For centuries, astronomers have sought signs of instability in red supergiants, hoping to identify precursors to supernovae. As these stars near the end of their nuclear fusion processes, certain signs of instability, like sudden dimming or brightening, may signal an impending collapse. However, the relationship between brightness fluctuations and a supernova is not straightforward. For instance, the red supergiant Antares, like Betelgeuse, exhibits notable brightness fluctuations, yet it has not exploded into a supernova despite its instability. Brightness changes in stars like Antares and Betelgeuse are often attributed to non-explosive phenomena. These stars can expand or contract due to pulsations or large convective cells affecting their luminosity. Although this behavior is common, it does not necessarily mean a supernova is imminent. Predicting supernovae based on dimming is complicated by our incomplete understanding of the internal mechanisms that drive stellar evolution. While current models offer insights, new data often challenge existing theories. For example, studies of red supergiants show that each star behaves uniquely, making it difficult to apply general predictions to specific cases. One emerging theory suggests that magnetic fields and internal oscillations within these stars could contribute to their brightness changes. If magnetic fields influence convection and mass ejection, this could explain why some dimming events occur. However, linking such dimming to a supernova remains speculative. In the case of Betelgeuse, the Great Dimming of 2019 to 2020 raised considerable speculation about the star's future. But the scientific consensus remains that Betelgeuse has not yet approached a supernova phase. Once a star nears the threshold of a supernova, the process is irreversible, with no possibility of returning to a stable state. Massive stars like Betelgeuse follow a predictable life cycle. Once their core accumulates iron, nuclear fusion ceases. The iron core eventually reaches a critical mass, triggering a gravitational collapse that results in a supernova. The energy released is vast, and the star's remnants may become a neutron star or, in some cases, a black hole. If Betelgeuse were truly on the verge of a supernova, it would not return to normal brightness as we saw after the Great Dimming. Instead, the recent fluctuations likely stem from other non-catastrophic processes. In a recent study led by researchers from France's Côte d'Azur University, advanced imaging captured Betelgeuse's behavior during the Great Dimming. The findings, presented in 2023, suggest that the dimming was caused by a veil of dust, primarily silicon monoxide, formed from material expelled by the star. This dust cloud partially blocked the star's light, leading to the dimming. Similar theories emerged from earlier studies, which proposed that Betelgeuse underwent a sharp decrease in temperature, expelling gas that condensed into dust and cast a shadow over the star. These findings offer insights into the behavior of red supergiants, suggesting that the recent brightening of Betelgeuse is likely due to the dispersal of this dust cloud as the star's temperature increased. As the dust cleared, the star's brightness returned to normal. Now, the big question: will we see Betelgeuse go supernova anytime soon? It's essential to remember that the events we observe in Betelgeuse today actually reflect a state from over 600 years ago due to the vast distance between us and the star. If Betelgeuse were to go supernova tomorrow, it would have exploded back in the 15th century, and the light from that event would only now be reaching Earth. While Betelgeuse will one day explode, determining exactly when that will happen is still beyond our current capabilities. For now, We can only continue to monitor its fascinating behavior and wait for the final awe-inspiring event whenever it may occur.